Welcome to today's video. This video is about why is the sun yellow? We see the sun nearly every day, but almost no one stops to question one of the most basic things about it, its color. Take a moment to step outside and look up at the sky, or recall the vivid hues of a sunset you've seen. Why does the sun look yellow from Earth when we know it's actually a blazing sphere of white-hot plasma in space? Why does it change color at sunrise and sunset? And what does Earth's atmosphere have to do with it? Today, we'll break down this everyday mystery in a simple, visual way that will make you look at the sky differently forever. Let's start with a surprising fact. The sun is not actually yellow. From space, astronauts see the sun as pure white. That means the yellow color we see from Earth isn't coming from the sun itself. It's created by our atmosphere. So, let's explore why. Sunlight may look white, but it's actually made of all the colors you see in a rainbow. Each color travels as a different wavelength. Blue and violet wavelengths are short and energetic, while red and orange wavelengths are longer and smoother. When sunlight enters Earth's atmosphere, it crashes into millions of air molecules, nitrogen, oxygen, dust, and tiny particles floating everywhere. Although violet light scatters more easily than blue light, our sky appears predominantly blue because our eyes are more sensitive to blue light. The violet light being scattered is less perceptible, providing the blue-tinted sky we typically observe. These particles don't treat all colors equally. They scatter shorter wavelengths, especially blue, far more easily. This scattering is what gives the sky its blue color. Blue light bounces around the sky, spreading out and filling our view. So what does that mean for the sun? It means that by the time sunlight reaches our eyes, much of its blue and violet light has been scattered out of the direct beam. What remains traveling straight toward us are the longer wavelengths: yellow, orange, and red. When that direct sunlight reaches your eyes, it appears yellowish white. In other words, the sun appears yellow because its atmosphere filters out the blue from the sunlight we see directly. Think of it like shining a bright flashlight through a thin, dusty curtain. Some colors get scattered away, while others pass through. The light that reaches you is different from the original beam, shaped by the air around it. But this effect changes throughout the day. At noon, when the sun is high in the sky, the sunlight travels through much less atmosphere. Less filtering means the sun looks closer to its actual white color. It's only slightly yellowish, but at sunrise or sunset, the sun sits low on the horizon. Now sunlight must travel through a much longer path in the atmosphere, about 10 times longer. With more air, there is more scattering. Blue, violet, and even green wavelengths are mostly scattered away. That leaves only the long, warm wavelengths: oranges, reds, and deep golds. This is why sunsets look fiery and dramatic, and why the sun appears orange or red during those moments. So if the sun is actually white, why do so many drawings, cartoons, emojis, and even textbooks show a bright yellow sun? Because that's how the sun typically appears from Earth, especially in clear skies and moderate altitudes. Human perception also plays a role. Our eyes are more sensitive to yellow and green wavelengths. When blue light is removed, our brains interpret the remaining blend of wavelengths as warm and yellowish. Let's break it down with an easy analogy. Imagine white paint made from all colors. If you slowly remove blue from the mix, the paint begins to look yellow. That's exactly what the atmosphere is doing to sunlight. But here's something even more interesting. Different places on Earth see the sun slightly differently. Consider the vibrant sunsets over Los Angeles, where pollution scatters more wavelengths, resulting in stunning orange and red hues. In contrast, the clear skies over the Swiss Alps offer a whiter appearance of the sun due to less scattering. In areas with high pollution or dusty air, more wavelengths are scattered, making the sun appear deeper orange or red. In apparent mountain air, the sun may look much whiter. So why does the sun ever look yellow at all? Here are the three big reasons. 1. Atmospheric scattering blue light is scattered across the sky, leaving the direct beam richer in yellow and red wavelengths. 2. Human perception. Our eyes respond strongly to yellow, making the sun appear warmer than it truly is. 3. Earthbound perspective from space. Without an atmosphere, the sun appears as a pure white star. This interaction between sunlight and Earth's atmosphere explains not only why the sun looks yellow, but also why the sky is blue, why sunsets are red, and why sunlight isn't the same color at all times of day. When you look at the sun, you're seeing a filtered version of its actual color shaped by the thin blanket of air surrounding our planet. And here's the thought-provoking part. The color of the sun we see on Earth is unique. Only planets with atmospheres will see their star with a tinted color. An alien species living on a world with thick clouds or a different atmosphere might see their star as greenish, pinkish, or dim red. Imagine what the sun would look like on Mars with its thin atmosphere and reddish dust. It might appear a soft, dusty gold. On the other hand, on Venus, with its thick, swirling clouds of sulfuric acid, the sun might take on a ghostly, muted glow. The color of a star isn't just physics, it's also a story told by the atmosphere of the planet observing it. Picture these alien skies and let your curiosity soar. So next time you look up, remember, you're not just seeing the sun. You're seeing sunlight shaped, sculpted, and transformed by Earth's atmosphere, a daily display of physics, perception, and cosmic light. If you enjoyed this video and want to learn more fascinating science facts, hit like and subscribe for the full playlist. The link is provided in the description. Thanks for being curious with me today. I truly appreciate your time and interest. Stay tuned for more exciting content.